So in this part of the series, I want to make sure that when we hit our enemies that they can be knocked back a bit. So we could call that, say, a hit or knockback state. Also want to be sure that gravity is affecting our enemies. And we may want to also do something like churn the color of the enemy red after getting hit to further indicate that our objects or characters are taking damage. So let's start with the simplest part first. Our player had the ability, if we check, to apply gravity, but we haven't added that to our parent class, the platformer character. So what we might want to do is take this apply gravity line, cut it, and go up one level. And then we'll implement the physics process function on this class too. So to do that, go here above try jump and do function underscore physics process, and we paste this in. So now what we should do on any class that is also going to call physics process, but is a child of platformer character, is we make sure we call the super method to make sure this code executes in addition to whatever else we add to it. So if we go to the player class now, and we have our physics process, we need to do, I think it's called super in Godot. So we just do super, and we pass in the delta, because physics process is still going to expect this delta. So we pass this into the parent class version of the function, let that run, and then execute our custom player movement script. So now any platformer character, by default, as long as we remember to call the super function, is going to apply gravity. So if we hit play, then the gravity should affect this character over here as well. Of course, we can see that this didn't activate here because we never called move and slide on that character. So there would be a couple ways of handling that. One would just be to do move and slide here, and then we would remove it from the player class. But we probably want to make sure that the super calls afterwards now. But if for some reason you need to separate when you apply gravity and move and slide so those don't execute in the same block, I think you could get away with also doing a call deferred on the move and slide. So we pass in the function name, or we could say move and slide dot get method, which is going to get the string name rather than setting the string hard-coded into here. And that'll make sure that move and slide gets called at the end of the frame. But I think I want to try this for right now. So move and slide will be called here. And when I'm designing classes, I just need to remember that the platformer class already calls move and slide on any object in the scene. So if we go to player, we just need to call super delta. And remember that that'll handle the rest of the physics processing. If we hit play, now our character should fall to the ground. So we only need to call move and slide from one class, and they're all affected by physics. So next, especially for our invader, he's going to have multiple states. So there's going to be a hit state, a death state, and a walking state, possibly even a seeking player state if we want to give it a little bit of a computer brain so that it can actually target the player and run towards it. So even though we're working on a simple enemy for the invader, he is still going to have multiple states. For instance, he's going to have a walking state, a hit state, and a death state at a minimum. So 3 separate states, and each of those states needs their own code. You can, of course, pump everything into one script. You could just create an invader script, but there are more elegant solutions to handling that. For instance, one way is to have a state machine as a node, and then child states below that. Another option would be to go to the asset library and look for, I think we want behavior trees. So if I can look for that, Behave is a behavior tree AI for Godot engine. So at a glance, we can look over here and see that Behave, using behavior trees, allows you to create a pretty complex AI situation for your enemy. Now, of course, to specify, when we're talking about AI in this instance, we're not talking about generative AI where it analyzes, let's say, 1,000 photos and then generates a photo that's similar to those. We're talking about AI where you hard code every bit of it. It's just separated into different pieces in a behavior tree. So big distinction there. Game AI is usually the second, not the former. So we're going to try to set up behave for our behavior tree for our character. This kind of method just ends up being a little bit more flexible in the end than state machines. So we're going to try using behave for our character. This kind of method ends up being a little bit more flexible in the end than a finite state machine because it allows us to use all of these nodes to help us navigate what the character should be doing at any given time based on settings on the character. So for instance, we could say that something like when the character drops below half health, it should run away. So that could be an option, and that would be pretty easy to set up with the behavior tree. So we'll keep it simple for this video, but I just want to introduce this plugin as one of the AI options. So I'll download this, and we will install it to add-ons/behave, install. So if you have any questions about the Beehave plugin specifically, you can find the documentation at bitbrain/beehive. Note the period right before the .in right here. And yeah, that will basically detail everything about the plugin. So for our tutorial, we'll just set up a simple tree. So back inside of Godot, I'm going to go to project settings and make sure we enable our plugin. So Behave, enable that, currently in version 2.8. Now if we right click Invader, we should be able to search Behave and find the Behave tree, which is the root of all of our Behave, which is going to be the root of all of our behavior tree logic. So I'll add in Behave tree. And if we hover over this warning, we'll see that it should have exactly one child node. So we need to right click here, add child node. And let's start with a selector composite. So this will execute our children sequentially until one of them returns a success. So basically, if one of our logic nodes is able to run, it'll return success and we don't continue on to the other ones. Otherwise, it will go down the tree and select the other behavior logic to run, and if the conditions are met for that to run, it'll run it instead. So let's do selector composite. So under here, we're going to want to add in a sequence composite. So our sequence composite has basically a list of actions or conditions that need to be met in order to finish the completion of it, and if all of them complete, it would return success, I believe. So we want a sequence composite, and then under here, let's add in a condition. So add a leaf node. Our condition needs to be met in order for us to take the action leaf below it. And then in the action leaf, we'll actually write the code for what our AI is doing under those conditions. So condition leaf. Okay, so then in addition to the condition leaf, we're going to need an action leaf. I'll add that in there. So our most prioritized action, I'm going to say, is if the character is dead. So I'll rename this IsDead. And then the action leaf is going to be to play death. After that occurs, we're going to remove the character from the scene. Okay, so this is going to be the death sequence. We can add another one in now, add child node. So this will be another sequence composite, and I'll duplicate that. So the first one is going to be the hit sequence. And then if that fails, so our character is not dead and our character is not currently hit, then it's going to be the wander sequence. So let's add in here a leaf for the condition. I'll rename this to be isHit. Let's add another action leaf, play hit. And then the wander sequence is going to just be a action leaf, wander action. So if we actually run the project now, we'll be able to go to the debugger and click over here on behave. So we have 3 behave trees running in the scene, and we can kind of see what's going on with the logic here. So basically, it's going to go down the first one of the death sequence. And if that succeeds, it's not going to continue to the hit sequence or the wander sequence. So obviously, our enemies are not dead. So we need to be sure that we set the condition before playing death. And then playing death actually needs to do something before we move on to the hit sequence and the wander sequence. So let's stop that. I'm going to rename this tree to be Invader Behave Tree. So now we can see in play mode that that'll be more specified here. So we know, of course, that this is part of the Invader. So to actually add the condition for IsDead, we need to right click and extend the script. So condition leaf IsDead. And we could actually put this in objects, I think. So in objects, let's say we'll have a behave folder and the IsDead condition leaf. Okay, so we'll create that. Okay, and how these condition leaves work is you implement a function called tick, and in tick you determine whether it is a success, a failure, or to basically continue checking. So we implement function tick, which is going to give us a actor, and it's also going to give us a Blackboard. So a Blackboard is basically an object that is going to hold certain pieces of data, and we don't know the full extent of what can be set in there because I think it operates as a dictionary that will be adding and removing items from it. But we can check the Blackboard to see if the property is set in it to the value we would expect and use that to determine true or false whether the character is dead. So somewhere else, we target this Blackboard and we set the IsDead property. And then in our tick function for this condition leaf, we check if IsDead is true on the Blackboard, and if so, then we will return success. So we could say var IsDead equals p Blackboard dot get value. And we're going to be looking for a key value. So this might be another situation where I want to have a data set that I keep consistent with all my AI scripts. So basically, if we're looking for death across anything, then I want to keep the Blackboard names consistent. So I guess I'll create a new script in the data folder. We'll call this Blackboard names, or Blackboard keys, actually. I think makes the most sense. This will be a resource. We'll create that. Inside of this resource, we'll have the export var, let's say death key string name, which will be equal to death. This class, of course, is class name Blackboard keys. And then we'll create a resource for that Blackboard keys and save that there. So blackboardkeys.tres. So now we'll just use this in our leaf script, but I got a note that I was actually editing the condition leaf from the plugin. So I'm going to cut that and make sure that I open up this script, which is the IsDead condition leaf. So class name IsDead, which is a condition leaf. And that's where we should be implementing this tick function, not changing the original script, of course. So at export var, and we'll say keys, which are going to be Blackboard keys. Then we're going to look for the keys dot death key. So we get the value there. Now we just need to assign Blackboard keys.trs and the inspector for IsDead. Okay, now we have our key names. Cool. So we get the value from keys.deathKey. So this we expect to be a Boolean. So we could mark that there. And then basically, if IsDead, then we're going to return success. Else, we're going to return failure. So if the character is dead on the Blackboard, we return success, and then we try to play the play death action sequence. Otherwise, we're going to return failure. So right now, nothing is setting the Blackboard values, so this will always return failure. If we go to the behavior tree, we can create our Blackboard here. For some reason, it's set to a node there that probably doesn't exist, but what we should do is create a Blackboard node in our hierarchy. I'm going to right-click on Invader Behavior Tree, add a Blackboard. I kind of like this at the top, and then we'll assign the Blackboard to the Blackboard node. And now this Blackboard is going to automatically get passed into all of these tick functions on basically anything that's running in your tree as an action or condition leaf is going to have access to this Blackboard. So as long as we set the dictionary values in our Blackboard, we'll be able to read from those in our scripts. Okay, so let's add a breakpoint in our IsDead script. We'll hit play, and it should run into this. But it looks like we're getting an error there, so I guess we have to put Blackboard outside. And we're still targeting it in the behavior tree. So that's fine, just make sure your Blackboard's out. And in the script, we want to set a breakpoint, so we'll check IsDead at our breakpoint, which we would expect to be false at this point. So we come into there, of course, trying to assign a value nil to a type of Boolean is an error we would expect because there is no values in the tree. If we check the Blackboard object, we can see in its dictionaries, and I don't remember if it's in the data of the Blackboard, but we would have in here the value for the death key. That's not being set, so we need to set that in something else in order to read that properly. So we actually kind of want this error to pop up because that's a pretty big issue. So I have been thinking a little bit about this one. With the Invader stats, we might actually want a health component that's separate from that. And then when the character dies, we don't have the Invader stats / object stats necessarily calling the death signals. But we'll still have the Invader stats for all of the statistics about it. But for our current health, we can pull that out to a health component, and that health component can mark the Blackboard with the information it needs to for when the character dies. So let's add to our Invader a new node, and at the top, I'll just call this the health component. We'll create a script. It'll go in the objects folder, so not in characters enemies, but objects/health.gd. This will get a reference to the stats of the object stats. And then this will also have the current health. So for our current health, which is going to be an int, and function ready will say that the current health is equal to the stats.max health. Okay, so this means that our character enters the scene for the first time, and unless we override that with something else, it's going to be initially set to max health, which we pull out of the object stats. So for the Invader stats, we can load that in from Invader stats. Let's look for the stats script inside of our project. So we have character stats and object stats. I want to take the death signal, and I'll put that in the health class instead. So let's put that up here. And then in object stats, the current health, we're going to paste this into there as well. And just override what I had just wrote a second ago. So we don't really need a default value here because we're going to set it on ready. And this will be the health node. So our health node is going to have a reference to the Blackboard, where whenever our health node dies, we'll set the Blackboard value of IsDeath to be equal to true. And actually, that's the death key death. So death will be true. Okay, for that, we'll need a reference to the Blackboard. Okay, maybe we also put in a alive signal. Or, you know what, let's change this. Is alive signal. So this will be a value, whether it's alive or not. And let's make that a property. And I'll also call it is alive changed. So we can make this into a property now. Var is alive by default is going to be true. But we'll do a setter function. So if the value is the isAlive value, then we're going to return because there's no change. It's already the same thing. Otherwise, we're going to set the isAlive to the value, and we're going to emit isAlive changed with the isAlive value. So now whether this is set to false or true, it's going to emit a signal anyway, and I'll do a .emit here. Because remember, we're doing a signal, so the new value will be emitted, and we can use other scripts to respond to that. And instead of this bit, let's also have another signal in here. So signal health changed, and we'll have like a new value and an amount that it changed by. So I'm going to comment this bit out here, and we'll say health changed.emit, and the new value is going to be current health. And the amount changed, so that'll be amount changed is equal to current health minus old. We pass that in here. Okay, so now we have those two parameters from our signal. But if the current health is already equal to the value, I don't want to bother emitting a signal because nothing's changed. So if current health equals value, then we'll return. And I'm going to reverse that also down here. So if isAlive equals value, then we'll return. Okay, so we have this signal, and we can actually connect to the signal within their own class as well. So I'm going to say down here, healthChanged.connect on healthChanged. So we'll create that function on healthChanged, which we get the new health and the amount changed. So whenever the health changes, we just want to tell isAlive equal to if the health is above 0 or not. So isAlive equals current health is greater than 0. So we update this Boolean property whenever we update the current health now. And that basically handles our health script for right now. Okay, now I could also have the health script directly set the Blackboard, but rather than permanently constraining our health script to the Blackboard and the Behave tree necessarily, what I will do is have a enemy Blackboard setter script. So basically it'll connect to any other components, grab their signals for like isAlive changed, and then set that on the Blackboard as a in-between step. So I'll right click on Invader. Let's add in a node, and I'll position this, let's just say under Blackboard. So for this node name, I'll call it object Blackboard setter. So for any object that needs to set the Blackboard, we'll use this script to do that. So I'll put this once again in the objects folder. Let's open that, create it in there. To set values on the Blackboard, we need to get a reference to the Blackboard. So export var Blackboard of type Blackboard. And remember, whenever we have the plugin installed, the Blackboard, we're specifically talking about the BehaveTree Blackboard. Other plugins may have something similar, but just keep that in mind. So we have that, and our object needs to update the Blackboard whenever its health component changes isAlive to false or true. So we need a reference to the health component at export var health, which we can do the connect disconnect trick I like to use. So if instance valid health, then health.isAlive, we're going to disconnect on isAlive changed, and I forgot the underscore changed part. Then we're going to set the health equal to the value, copy paste this down below, and then just change disconnect to connect. Okay, so now we're connected to the signal on the health component. We need to create the onIsAlive changed function. So this is going to have the boolean of the value. So p-value boolean, and basically whatever the value is, we set it on the Blackboard. So this is going to be for the death value on the Blackboard. So Blackboard.setValue, and we need a reference to that key. So let's get the keys resource at export var keys, which is of type Blackboard keys. So keys.deathKey. It's going to be equal to the p-value. And I think as a last thing, we maybe want the ready function to set that on ready. So function underscore ready. We're going to take the blackboard.setValue of keys.deathKey to health.isAlive. Okay, so before we receive a signal, we've already set the value on the Blackboard, which is going to hopefully mean that it can run immediately. If not, then this might need to occur before other things happen, but we'll see if this works on ready. So assign the Blackboard. We'll load up the resource Blackboard keys from the data folder and assign the health component. And that should set the Blackboard up with the values it needs for IsDead to be set here and get the value so we can use it in our BehaveTree logic. Okay, so let's hit play now and see if that's working. Okay, so I did some testing, and it seems like when you try to set the Blackboard values on the ready function, that the Blackboard actually resets its default values. So there's a couple ways to handle this situation. I guess using onReady is not the way to do it. One would be that on the Blackboard, we could manually add in the key, or we can just default until this value has been set to something new, that we have something set in our scripts. So if we go to IsDead and we try to get the value, the death key, then we can just say that by default, this is false. So basically the idea is just that the Blackboard, we should wait till everything initializes before we try to set anything into it. I don't know why it's set up like that, but that seems to be the case. So the Blackboard setup will just be updating the value with new values after the script has already loaded. So if I add this back in, I bet you could actually do something like call deferred. And this is a little hackish, but let's do blackboard.setValue.getMethod. And then we give it the parameters, which is going to be keys.deathKey. And then just for testing purposes, let's say this is true. So we'll go to IsDead, and this should be false by default because that's the default. But I'll set a breakpoint here. So if we were to go back to the Blackboard setter script, and I did something like, let's change this to function underscore physics process. And then every time we run physics process, we set this to true. And this is just purely for testing. Then on physics process, it should be able to update here. So by default, this is false. So once we set it, it's going to give true. If we run the current scene, the first time we run it, I guess the physics process has already actually ran. IsDead is set to true. If we check the Blackboard, then there we have the death data listed inside of there. So yeah, I don't know the exact reason, but be careful with trying to set the values on ready, I guess, at least in the current version of the plugin. We'll just have onAlive changed to set that as we need. But by default, every object in the scene for IsDead is just going to default to false until we set the death to false. And actually, to make this make a little bit more sense in the data for the project, in Blackboard keys, we're going to say isAlive. This would be isAlive. Okay, so that when we're responding to the signal, we actually set the isAlive key to the value of isAlive changed. Okay, so you see how that makes a little more sense there. And then on IsDead, we're going to get the isAlive value, but of course, we want to reverse that. So IsDead is going to be not isAlive. And if IsDead, then we're going to success, otherwise we're going to fail. So initially we should be failing this because the character should be dead by default. But it's still set to true here because I need to change the default value for is alive to true. Okay, so by default, we assume that a character is alive until we've set the value in the Blackboard for is alive to false. If I run this, okay, IsDead is now false, and we will not succeed. And if we go hit play and we look at the Behave debugger, we should see that we're failing the death sequence there. Okay, so we can see what's happening here. We get the death sequence, IsDead fails, so we go to the next one, the hit sequence. We haven't set up the isHit condition, so we automatically proceed to the play hit action, and until we fail one of these, we won't do the wander sequence. So I was getting a little stuck there myself, but hopefully now that we got that going, knocking out the hit sequence, the play death logic, play hit logic, and wander action logic should be a bunch easier to understand. So let's stop the scene and clean things up a bit. If we shoot an enemy now, then we'll see that the Hurtbox now cannot access the current health stat of the object stats. So instead of referencing the object stats in the Hurtbox, we should actually be referencing the health component now. So health and then health here. So we'll do the health.current health. So now down here in hittable, we want to check health.current health is greater than 0 instead of on the stats. So if we stop the scene and we look at our Hurtbox, we need to assign the health script so that we know where we're checking for invincibility from. Also on the current health property, let's look up the symbol, right-click lookup symbol. I want to make sure that this is never set to more than the max value of the object stats max health. So the value here that we set to current health is actually going to be the min of either the value and the stats.max health. So that's just to make sure that the current health is never set to a value more than the max health, regardless of how we do it, how we get that value for the current health. It'll always be capped at the max health. Okay, let's hit play and see if we can clean up a couple other things. Shooting. So the hitbox was dealing damage to the Hurtbox by just subtracting the damage dealt from the current health. But we're going to also have knockback. So we should have a signal on the Hurtbox that we can subscribe to. So when we get hit, we can basically mark the character for being in a hit state. So let's say Hurtbox.hit, and we're going to say the amount of damage. So we're now going to be saying Hurtbox hit damage, and then this will give the actual amount dealt as a return. So we don't need that. So we'll cut this weapon stats.damage, pass that in. The dealt is going to be put down here. And then we're not going to automatically subtract the current health. We're actually going to let the Hurtbox manage that. So in Hurtbox.hit, we need to set that up. So function hit. And maybe later we'll add something for the knockback. Haven't decided on that yet. But for right now, I want to figure out how much damage I actually dealt. And this should be returning an int, not a boolean. So we're going to check the old health is var old equals health.current health. And then for this, we're going to basically add the damage to the current health and compare the two values and return the difference. So health.current health minus equals p damage. And then the var damage dealt, let's say, is going to be equal to the old health minus the health.current health. And we'll return the damage dealt so that our hitbox can know about that. And when the hitbox knows about that, we'll emit the Hurtbox, the dealt damage, as a signal. And that should handle that. So let's hit play and see if we've cleaned up the errors now. 1, 2, 3, 4. Okay, if we shoot another time, well, that character's dead. Now, the death animations aren't playing because we basically disabled that script from the character sprite. So once again, we're not connecting to the character stats in order to play this on death. We're going to handle that in probably the next video or the next couple videos with our Behave tree. So that's going to be it for this video. In the next part, we're going to continue working on our Behave tree and get all of this condition and action logic set up to basically set our characters up with their AI logic. And we're going to keep these conditions and actions as reusable as possible so that we can just pop them into a completely different character or object's Behave tree as well. So by separating it into each of these individual scripts, hopefully we'll be able to achieve that. So I've been Chris. Thank you guys for watching to the end. If you need the snapshot for the project, I'll have it on Ko-Fi and Patreon. And I will see you guys in my future video content.